Welcome to P. Clark Calc, Practical Calculus for the Busy Math Student. And in this video we're going to take a look at one of the nicest tools in the world of infinite series called the P-series convergence test. And there are a couple of examples that we're going to look at right now. Here we're looking at a couple of infinite series, 1 over n squared from 1 to infinity and 3 over the square root of n from 1 to infinity. And we're trying to determine just qualitatively, are they convergent or divergent? And there's a really nice quick way to do this. It's called the P-series test. And it applies to these types of series. And what it states is that if a series is approaching zero fast enough, that means that the sum can be calculated. You have to be a little careful when you're looking at infinite series because the terms going to zero do not prove convergence. If the terms don't approach zero, we have the nth term test for divergence, and we can state that a series is divergent if the terms are not approaching zero. But if the terms are approaching zero, that does not allow us to state they're convergent. We have to figure out if they're going fast enough. And the P-series boils this down to a quick and easy test. It's all proven from the integral test, but what it says is if you have a series on the order of 1 over n to the p, as n goes from 1 to infinity, or from any lower bound, really. The lower bound does not affect convergence or divergence qualitatively ever. So we typically use 1 when we're writing our definitions here. And what it says is that if p is greater than 1, the series converges. That means that the terms are going to 0 fast enough. And if the exponent is less than or equal to 1, it's a positive exponent as well. So between 0 and 1, including 1, then that's a divergent case. So it could be quite simple where you look at 1 over n squared and you look at that exponent there and say, okay, well that is 2. We call that our p-value. And since p is equal to 2, which is greater than 1, it means that the terms of this series are approaching 0 fast enough, and we can state that this is convergent. The p-series does not attempt to try to come up with a numeric value. It's a qualitative test. It's a nice, quick, and easy. It's the fastest of the convergence tests, really. And usually, with a little bit of practice, you're doing these by inspection. For the second one, there's a couple things that we could do. One is there is a radical there. We may not want to do that. And also, we can expand the p-series a little bit here. The constant multiple rule for series states that a factor of 3 could come out of the series. It's not going to affect qualitatively if this is converging or not. So we can write that as 3 times the series 1 over n to the 1/2. So in this example, we see that although the terms are approaching 0, that this exponent here, p is equal to 1/2, means that the terms are not approaching 0 fast enough. And so here we're looking at a divergent series. There's one really important case that you're going to see quite a bit of as you move forward here in the study of infinite series, and it's what happens when p is exactly equal to 1. And that has a special name. That's called the harmonic series. The harmonic series, by the P-series test, is a divergent series. And again, with a little bit of practice, that's just stated as fact at some point. So 1 over n, that is basically the borderline of what we call fast enough. You know, what series is approaching fast enough? So basically anything that's approaching 0 faster than 1 over n is going to be convergent. Anything that's approaching 0 slower than 1 over n is going to be divergent. So it's an important case because of that reason. But ultimately the P-series is a nice, quick and easy test that we use for many algebraic type series. With a quick up or down convergent divergent decision simply by looking at the explicit definition of the series. As always, at P. Clark Calc, we do practical calculus for the busy math student, but if you'd like to learn more about the P-series or the other convergence tests or anything about calculus in general, you can find them on my textbooks, which are available on Amazon for a really nice price. Until next time, I'm P. Clark.